Alrighty, so this comes from page 105 in the book, although once again they've made things far more complicated than it really needs to be. So I'm just going to briefly talk a little bit about vector subtraction here. As I was saying earlier, it was kind of a challenge in grade 11, and I just went through that with my grade 11s. It always is, and I always tell them it'll get better, and I'm about to tell you that it will get better, and you'll go, oh, well, that's easy. Why didn't you just do that last year? And the only reason it sort of makes sense to you is because we went through what you had to go through last year. So there is some method to my madness, okay? So you can jot this down. It's entirely up to you if you want to just sit back and sort of soak it all in and understand it. That's good too, right? It'll be up on Schoology a little bit later. So if you want to just sort of do some thinking, that works for me as well. All right, so I'm going to talk about vector subtraction. We know that the resultant is plane plus wind. So I'm going to use an example of a plane flying in the wind, right? So you've got like the plane flying here. It's going north, and the wind is traveling to the south. The W is going to the right. Thank you, east. There was only two left, Parker, to guess. So, yeah, the plane is going north here, right, Justin?
Yeah.
And the wind is going towards the east. And the overall resultant then would be like, that would be east of north, right? East of north. Okay. And the plus sign right here indicates that we are to arrange the P vector and the W vector. We are to arrange them tip to tail. That should be good for everyone, right? Yeah?
Sure, Mr. Brown.
Okay, awesome. Now, if the question happens to say, we want to know what the plane or the wind speed is, well then I'm going to rearrange my little formula there, and I get the plane vector is equal to resultant vector minus the wind vector, or if I'm solving for the wind vector, then it's resultant vector minus the plane vector. Okay, and I'll give you 5 seconds to sort of soak that in. Okay, all I did there was just rearrange things, right? All right, so this sort of sets up vector subtraction, right? This means vector subtraction when we're trying to find the wind or plane speed. I put W there, but it should be wind, really, I guess, right? When you're trying to find the wind speed or the plane speed, then you are going to do vector subtraction because you already know the result. Okay? And last year in grade 11, you had to take the wind. Remember, this led us to wind is equal to resultant plus minus P. And what we did was we took the P vector and we flipped it, right? Put it pointing the other direction, and then we just added, right? And it was kind of confusing. I mean, it's really not. And if I showed you guys now, you guys would go, yeah, I can do that, because you've got enough physics experience that you can handle that level of complexity kind of thing, okay? But I'm going to show you a different way, okay? And it's pretty simple. To subtract vectors by components, all you do is subtract the components rather than add them. That's it. Theoretically, I could stop there. Obviously, I won't. I'll explain a little bit more. Okay? But that's all you have to do. Instead of adding the components, you're simply going to subtract them. Now, the key is that your positive and negative signs have to be set up right, and you got to be careful with them. But for the most part, it's pretty straightforward. So suppose we have a situation like this, where I've got vector C, and I have to subtract A minus B. And I purposely did not use resultant or plane or wind. I'm just using generic vector names, C and A and B. And I've got it, basically I have to go A minus B. Okay, A minus B. And A is 12, 12 whatever, I guess. I didn't even put it on there what it is. Does it matter what unit it is?
No.
We'll just ignore it, right? Could be meters, could be kilometers per hour, could be whatever, newtons, what have you. So I've got east 26 south, and I've got east 14 north. Okay? So in grade 11, what we would have done is we would have gone east 26 south, which is like this, and I subtract the B, which is going to be a west 14 south. West 14 south. So I would go minus B like that, right? This is A, and that's minus B. And then your resultant, or your C, is that one right there, right? And people had some challenges doing that. Okay? So with components, it's super, super easy. Okay, so here's what I'm going to do. I'm just going to get my screen shade up. All right, so there's my vectors again. And if you wrote them down already, that's fine. I just needed them there so I could have them all on one page. I'm going to go A is 12, east 26 south. So that's east 26 south, right? That diagram. right? Okay, the angle here is 26. This is my AX, this is my AY. AX because X is horizontal, left to right, and the Y is the vertical up and down, right? And so the AX is adjacent to the 26, and adjacent has which one? Sine or cos? Cos, right? Right, so it's going to be 12 cos 26 because that's adjacent, and the AY is going to be 12 sine 26. And now I got to get a calculator out because I don't actually know the answer. 12 cos 26. 10.8. Riley, I'm going to ask you if it's going to be positive or negative, knowing that to the right is positive and to the left is negative. AX. To the right or is it to the left? So therefore it's positive. Now, do you have to put the positive sign in there? Not really. Would it help? Maybe. Tough to say. Probably different for different people. 12 sine 26. 12 sine 26 is 5.3. And Braden, is that one up or down? AY. It's going down, so that makes it a negative, okay? And that's really, really important to get that right, okay? Really important. Now all I do is
subtract.
no, I don't have B yet, Justin.
We'll find it. Jesus. What are you doing?
Got to find B first, right? Now, do I flip here? Do I have to flip the direction?
No.
No. Do not flip. Okay? Don't flip out on me. Oh, thanks, Parker.
No,
I don't usually get a little left check left. Parker, that's good. So, the x is adjacent, so it's cosine, so 8 cos 14. 8 cos 14 is 7.8. Alvin, left or right? So it's
Negative.
8 sine 14, 1.94.
Negative.
Is it?
Yep.
Why?
I'm joking.
Positive. Okay, then I set up my subtraction, and all I go is CX is equal to AX minus BX. And that's because of the question, right? I'm subtracting A minus B. So that's simply going to be 10.8 subtract 7.8. Oh, that worked out nice, didn't it? 3. And then CY is going to be AY, which is minus 5.3. Make sure you put subtract, and then, oh, this is a problem right there, isn't it, right? That should be a B, shouldn't it? Yeah. That is going to be 1.94. I don't think I can do that in my head. I don't know why I did that two decimal places, but negative 5.3, subtract 1.94.
Got him.
Negative 7.2.
Remember how he said he was chewing on his
Yes, I do remember that.
Yeah.
All right, so what would be the next step? I got my CX and my CY. I've broken it into components. I've done the subtraction. Now I have to
Add.
put them back together. When you say add them, what do you mean by that, Justin?
I'm
Because you're right.
being a dummy.
No, you're right.
Well, I don't know.
Like, can I just go 3 plus or minus 7.24?
No.
No. What do you mean by add them? It means you got to add them by vectors, right?
Yeah.
Should I draw a picture?
Yeah, sure.
Problem. So that's 3. Why is it to the right?
Positive.
Because it's positive. Riley, is this one going to be up or down? How come? Because it's negative. And this vector here is actually my result, which I'm going to call C, right? And how do I find that C? Yeah, exactly. Thanks, Justin. C squared is 3 squared plus 7.24 squared. Do I need to put my negative sign in there?
No.
No, because it really just means the direction, right? So C equals, you should be able to sort of work that out. Squared plus 9. And I get an answer of 7.84. Am I done with that? Last thing.
What did you do?
I think it's okay. Last thing to do is find the angle, right? So that's going to be inverse tan, opposite over adjacent, 7.24 over 3.
Right.
67. 67 degrees. So that's going to be east, 67 south. Okay? Okay. It's really just an example of vector addition. Okay? So we're going A minus B. So let's just quickly go through the steps here just to sort of summarize kind of thing, right? So the first step would be to break it into components, right? Break it into components. Make sure your positive and negative signs are correct. Subtract your corresponding components, right? Subtract your x's, subtract your y's, and then do what? Be like Humpty Dumpty and put them back together again, right? Is this always going to be a right triangle in here?
So,
How come? Because you're right. How come it's going to be always a right triangle?
I don't know, because it's too weird.
It has to be, right? Because they're x and y, right?
Yeah.
They have to be. It's always going to be a right triangle, which means you can always use Pythagoras, right? And then it's always going to be tangent in here as well. Okay, so yeah, is that good?
Yeah.
Yeah? Good. All right. There are, I know, there's a few questions there in the book. Those ones are more sort of word problems, I think. They're not sort of just, here's one minus this one kind of thing. And I do have a worksheet over there as well that I'm going to give to you as well. So you can have the rest of the period to work, and today should I sort of do a what's going to be on the test kind of thing, or should I wait till Tuesday?
That's it.
Right now, bro.
Yeah, do it now so we have all weekend.
Okay, I'm not quite ready for right now, but how about I give you a few minutes and I'll come back? Okay? All right, so it's been about, what, 3 weeks, 3.5 weeks of classes kind of
7,
thing?
Mr. Bennett.
Has it been 7 weeks, Justin? You'll remember one of the first things I gave you was that 2-column sheet,
I don't.
right? The 2-column sheet, position time graphs, velocity time graphs. There will be lots of questions on position time graphs and velocity time graphs. Right? Lots. So dt graphs, dt graphs. Right? You'll have to be able to read them. And you'll have to be able to construct them, like from one to the other. Yes, I know, but it's in the curriculum. I got to teach it. Now, having said that, am I going to have like 8 questions on that?
No.
No, of course not. One of each, probably, right? And then it'll tell me, do they know how to do this? I don't need 6 to tell them. I just need 1. Okay? It'll likely be different. Like, I mean, there's a good chance it'll be worth 3 or 4 marks, and there'll be 3 or 4 segments to it, right? Some that are easier than others. Right? There will be some where I'll say, like, here's a dt graph, what's the corresponding vt graph? More of a multiple choice kind of thing. Then there'll be others that you have to draw, right? But I mean, the basic outcome, the basic thing you got to know is what vt graph do you get from this dt graph, and vice versa. That's what it boils down to. Okay? And we spent, I don't know, what did we spend? Maybe 3 or 4 days
7.
going through that. There was a couple of little flowchart thingies that may help you. Like if you're looking for this and you got this, then do this. They're in there. Am I going to ask you to fill in a flowchart? No.
You're going to ask us to fill in 7 of them.
No, I'm going to ask you, can you solve this problem? And you have to know how to solve it. That's what it boils down to. Okay? I will give these back to people, those ones that you handed in, okay? In fact, some of you, I think they should all be in now. I'm going to give that back to you today, because you should have it for the weekend, shouldn't you?
Yes.
And those of you that didn't hand it in, well, you're just going to have to do a different one, because it's too late. Too late. Okay? So yeah, we did lots of graph stuff. Okay. Then I derived the equations. Am I going to make you derive an equation?
7 of them.
No. I said you only have to
Use
experience, right? Yes, I showed them how to drive an equation. Get a cheat sheet, half page, single side.
Sweet.
Now, having said that, do you need to know those formulas? Yeah, you sure do. And what are those three new ones? VF equals VI plus AT. V equals VIT plus a half AT squared. And VF squared equals VI squared plus 2AT. Right? And if you've done enough problems, you'll just know them. Oh, you're also going to have on your cheat sheet x equals minus b plus or minus square root b squared minus 4ac all over 2a. Why is Darren listening to music right now? Can you? Justin is too. Parker is too. No, doesn't make a lot of sense. Oh, I apologize that I missed you, Troy.
What's that say? VF.
VX squared equals VI squared plus 2AD. Okay? And you're certainly going to have, we all know what a physics test looks like now, right?
No.
You're going to have to solve problems. And there's going to be some that are going to be 1 mark and be a couple that are 2 marks, and there's going to be some that are 3 and 4 marks. Right? And it's a matter of have you done enough work to be able to handle something like that. Have you done enough problems? If you haven't, spend some time this weekend.
Huh?
I know it's not fun.
You don't know that quadratic formula?
No.
There was a booklet of problems. There was also this booklet. Well, it was the same booklet. The booklet with the questions on the front. Do you think any of these kind of questions could be on there? To
7 probably.
To check. Actually, 7 is a good number for that. Okay. You know, like I might ask you, like, can the velocity of an object be 0 at the same instant its acceleration is not 0? Okay. And I went through those answers, and I know that I posted it up to Schoology too, so you could go find that. There was lots of problems there. And then we got into the textbook problems, which are a little bit more challenging. And sort of the ultimate problem to really test your understanding is what I like to refer to as the Fred and Barney style, right? Or the Jack catches the bus. Right? I would suggest that you have a close look at both of those. Because that really is a good test of your understanding. Okay, and then we got into vectors, right?
Is vectors on the test?
Absolutely.
Mr. Bennett, come on, man.
Get real.
And if I had to break down vectors, it would be adding, subtracting. I guess the first part would be components, right? You got to be able to break them into components. You got to be able to add them. You got to be able to subtract them. And what goes along with that are word problems. Okay. No ruler required. No protractor required.
Good. That don't happen.
Like really, when you break it down like that, there's not a lot. There's not a lot of individual pieces, really, is there? Right?
Never mind, look, just 2 little sticky.
It's can you do the graphs? Can you do the word problems? Can you do the vector problems? There's your 3 big things. Like Fred and Barney, or a ball is dropped from, and that kind of thing, right? And there's no real way to study for them. You just have to
Do them.
Yeah, do them. Do them, practice enough till you get to the point where you feel fluent, you feel comfortable. I can do this. I can do it. And if you have to, get the solutions, get the QR reader, beg me to get the green binder, whatever you need to do to get the solutions. And if you have to, just start writing out solutions to problems. And eventually it's going to start clicking in. Oh, I've seen this kind of thing before. I can do this, right? You guys can all do this. You've been through grade 11. You can do it.